Hello students. In the previous lesson we had found out an expression for the drift velocity of electrons in a conductor. The expression was Vd is equal to minus Ee by m into tau, where m was the mass of the electron and tau was the relaxation time. Today in this lesson we will find out a relationship between current and this drift velocity. To do so, let us take a conductor of area of cross section A. Now we will divide this conductor into two very small portions. Say this is cross section 1 and a little distance from here, very small distance, let us say we have another cross section 2. Now when you apply an external electric field to this conductor, electrons will start drifting. Okay, now some electrons will be passing through this area A and will be reaching the area of cross section 2. Say the small interval of time in which the electrons reach from area A to area 1 to area 2 is dt. So we have a conductor which is subjected to an external electric field E. Okay, then we have area of cross section of the conductor as A and let the length of the conductor be L. Now we have something called electron density of the conductor. Here we don't take the total number of electrons, we take electron density by denoted by the letter N, which is nothing but number of free electrons per unit volume. So with the help of this N, that is electron density, we will find out the number of electrons crossing this area of cross section 1 in a small time interval dt. Let's start now. To find the number of electrons passing the cross section 1 in time dt, it is given by electron density multiplied by the volume. Because it is number of electrons per volume, if you multiply this by the volume, you will get the total number of electrons. Now what is our volume? Since it is a cylinder, the volume will be equal to, this is N, the volume will be equal to area multiplied by the length. Now we will not be modifying this N into A right now. We will be just looking at this term L. Now L is the length, say we have certain length of the conductor through which the electron is passing. So this becomes a distance which the electrons are traveling in a small time interval dt. Now distance is equal to velocity multiplied by time. So this distance in our case is L, will be equal to the velocity, we take it as the drift velocity of the electrons in the time interval dt. So instead of L, we are going to write Vd into dt. So this is the number of electrons passing the cross section 1. Now with the help of the number of electrons passing the cross section 1, we will find out the total charge passing through this area. How will you find the total charge? You will find out by just multiplying this number by the charge on one electron. Alright, so the total charge passing through 1 in time interval dt is given by the number we had as N into A into Vd into dt into the charge on one electron, which is nothing but E. E is taken as a charge on one electron. Now this is the charge passing in time interval dt. Now with the help of this charge, we can easily calculate the current passing through this cross section. The formula for current or from the definition it is a rate of flow of charge. So it is, say this is dq, it is rate of flow of charge dq by dt. Our dq was this much, so current I is given by N A Vd into dt into E divided by dt. We could cancel this dt. So the current is equal to, we'll arrange the terms properly, Vd into E into N into A. This is the formula for current passing through the conductor in terms of the drift velocity. Now, what will be the effect of temperature on current? Let's replace the value of Vd here. I is equal to, Vd was from the previous expression that we had derived in the last class, EE by M into tau into E into Na. You can see this E, that is charge on an electron, is a constant. Electric field that you have applied will be a constant for a given situation. Mass on the electron will be a constant. Again, E is a constant. Now electron density is a constant. The area cross section of the wire is also a constant. So the only thing that can change on changing the temperature is this relaxation time. So if we increase the temperature, let's analyze what happens to this relaxation time. Electrons, relaxation time is the time interval between two successive collisions. On increasing the temperature, they will start colliding faster. That means this will decrease. Now, if this term decreases, naturally the value of current will also decrease. So, increase in temperature will result in decrease of electric current in a conductor. Thank you.